Okay, good morning. Colored pens up and pencils go down. Make sure you are aware of your new number. So look at your desk to just get a quick refresh of your new number. Equity bars are in effect. And I'm looking for number 1, the solution to the system. The solution to the system. So for number 1, I've got students 21, 5, 16, and 3. Student number 21, 5, 16, and 3. 21, what'd you get?
1, -3.
Okay, student number 5, what'd you get?
1, -3.
So you agree with Angela. And student number 16, what'd you get?
1,
And student number 3, what'd you get?
-3.
So 4 of my students agree on the answer. Let's see if they got the right one. 1, -3. Very good. Then I asked you to graph the system. So this is not something that I can call on volunteers for, so let me reveal the system. And this is the graph of the system. So I appreciate that maybe a few of you got confused as what you were supposed to do. That's why I clarified about 2 minutes ago that I wasn't looking for you to graph the solution. That's super easy. That's ridiculous. I was asking you to graph the system. When I ask you to graph a system, I'm asking for the line that represents the solutions to the first equation and the line that represents the solution to the second equation. And to be quite honest, graphing these 2 lines doesn't get much easier. Could someone remind us, what form is that? What form is that? Melinda? Slope-intercept form, and that should be, for you, pretty easy to graph at this point. What's our starting point when we have slope-intercept form? Milan? -7. So boom, you put a point right there. And then what do we do next, Shannon?
Rise 4, 1.
Very good. Go up 4 over 1. So we go 1, 2, 3, 4 over 1. Boom, we end up right there. Draw a line. So at this point, this should be pretty routine for you. The other one may be a little bit more challenging. What method did you use to graph the other line? Someone help us out. What method did you use to graph the other line? Because I know some of you got it. Go ahead, Emily.
I did the opposite of A over B.
Did the opposite of A over B. Okay, and that got you what?
-1 over 1.
And that's the slope. Okay, but what was your starting point then?
-2.
How'd you know -2 was the starting point?
Because if you isolate y, then the point will be negative.
Okay, so you kind of, did you do that mentally?
Yes.
Okay, so she basically converted this into slope-intercept form. You subtract x from both sides and you get y equals -x minus 2, and then you can see that the y-intercept there is -2. She also has the slope here, or she figured out the slope opposite of A over B. Either way, that's great. And so she put a point here, and then went up 1 to the left 1, put another point, drew a line through it. So that's a great approach. What other method is really good for graphing when we have something in standard form? And we're going to be talking about standard form a lot today. What method of graphing works really well when it's in standard form? So things should be kind of popping at this point. Aaron? Yeah, the intercepts. How do you find the x-intercept, Aaron?
Replace the variable the y with 0.
Very good. Take the y, make it a 0, and now you got x equals -2. Look at that. X is -2 right there. And then how do you find the y-intercept, Aaron? Yeah, you take the 0 and put it with the x, and you get y equals -2, and there it is right there. Draw a line through it. So when an equation is in standard form, intercepts is a great method. Emily's method is just as valid. Guess what? Doesn't matter. You get the same result, a line. Okay? Anyone have any comments, questions on today's warm-up? Any concerns about anything at all? You got 1 comma negative 3? Oh, 1 comma 3. So you use substitution as I asked. Okay, so you made a mistake along the way in your computation. Okay, so I'm going to come look at your paper, and I'm going to try with you to find where you made a mistake to get a 3 instead of a negative 3. Here's the problem. If you did substitution, you should have found the x first, right? Because if you substitute this in place of there, you find the x first. Did you get 1 for the x? You said you got 1 comma 3, right?
Oh, yeah.
So then you made a simple mistake. Because once you have the x, it's easy to find the y. You take the x and you plug it in anywhere. You plug it in right there. Y equals 4 times 1 minus 7. 4 times 1 is 4. 4 minus 7 is negative 3. What's that? Okay, I'm going to come look at your paper. Okay? Any other comments, questions, concerns of any kind?
I got negative 3. I didn't get the x.
Yeah, because you had rewritten something I had seen on your paper. What was your revised equation that you had written? I think you had done the first one.
Yeah.
What did you change it to?
X equals negative y minus.
Negative y minus 2. Here's where you got tripped up, I think. I think you got tripped up right here. So you found the y first, correct? And so now you plug it in, and you put x equals negative 3 minus 2. I don't think you did that. You just put negative 3 minus 2. You put negative 5? Yeah. So unfortunately, you have to deal with this negative. Opposite of negative 3 is positive 3. Positive 3 minus 2 is 1. Okay? But you got to go back to the beginning. So Christian, you did a great job, but you did tons of extra work. Because you isolated the x in the first equation, but the y was already isolated in the second equation. You ended up doing extra work. Doesn't mean you're a bad person or anything. It just means you did extra stuff you didn't have to do. So try to make sure you look at both equations before you proceed, okay? Good. All right. Today, we're starting 5-3, which is solving systems using elimination. When I outlined the chapter for you, when we did 5-1, I talked about the fact that you were going to be learning 3 different methods for solving a system: graphing, substitution, and elimination. So you've already learned 2 methods. You're going to have the 3rd method by the end of today. The idea is for you to develop a toolbox. You're supposed to be developing a set of techniques and tools for you to use in different situations. Each technique works well in a particular situation. Also, there's comfort level. Depends on what method you become comfortable with. Well, I'm not going to give any of the secrets away, but so by the end of today, you're going to have a decent understanding of elimination, and we're going to work on developing the idea over the next 2 days. So, I like my students to have something to fall back on. So as I told you before, I outlined in a sequence of steps so that tonight, when you sit down and you're exhausted and you go to do the homework and your brain is not firing on all cylinders like it should be, and you can't remember a thing, you can look back and go, oh yeah, I remember now. Okay? So that's the idea behind this. I do not expect this to make sense to you right now, but by the end of today it will. So solving a system by elimination. First thing we want to make sure of is that the equations are in standard form. So this is why way back in chapter 3 we talked about standard form and recognizing it. And so that's why, and converting into it. So we want to make sure that things are in standard form. Okay? From there is the first new idea. because that you already know how to do. So we're going to do something, and this is not going to make any sense to you right now, but in a little while it will. What we're going to do is try to get opposites somewhere. And again, not seeing any examples, you're not going to understand. This is something for you to fall back on later. So what we want to get are opposites of one set of coefficients. So that's what we're trying to achieve. Opposites. So step 2 is new. You've never seen that before. And we're going to do this by a few different possibilities. We may multiply one equation by something. We may multiply both equations. We may not have to multiply either equation by anything. So again, step 1, that's not new for you. Step 2 is. From there, we add the two equations together. That we've never done before. So I put a star next to it. That's something new. And this is where the name of the method comes in. We add the two equations together, and what will happen is one of the variables will disappear. One of the variables will eliminate. That's good for us. That's the whole point. Because we want one equation with one variable. And so then we have all things that you already know how to do. Solve the equation that's left. From there, the rest is easy. The rest you already know how to do because it's the same thing you do with substitution as well. Once you get one of the coordinates, you plug it in and get the other. Use one of the equations and the value that you just found to get the other variable. It all comes down to remembering what you're looking for. I really like how I saw on some of your homework papers, really going out of your way to demonstrate that you were looking for an ordered pair, an x comma y. You have to really make sure that you remember that that's the focus. You're trying to find an ordered pair. Now, step 6, I don't want you to copy because it's something we just do no matter what. You've seen it before, is we check. We take the ordered pair, plug it back into both equations to make sure it works. So I don't need you to copy that down. That's something that you've been practicing for a while, and so that's something that should just naturally happen. Let me check and make sure my answer is correct. That's one of the nice things about algebra, or certain aspects of it, is that you should know if you did it right. I give you guys answer sheets on my website every night. Most of the questions, you should know whether you got them right or not. You should already know. Okay? We're going to talk more about that again today. So, if you are missing any of this because I went too quickly, that's okay. I've got it printed out for you. You can borrow my paper at the end of class and fill it in, so I would just leave a couple of lines of space. And if it doesn't make sense to you yet, don't worry about it, because it will make sense in a little while. Does anyone have any questions about just the terminology or anything that showed up here? Good, so let's go ahead and jump in. Today, I took the approach of starting with moderate level questions. We're going to go to some easier ones, and then we're going to do the hardest ones towards the end. So, let's jump in and learn how to use elimination. I don't want you to worry about part B yet, so let's get rid of that. So hopefully over the last couple of days you got used to substitution. We're going to have to shift the way we look at things a little bit. First of all, we want to make sure that everything is lined up. When I say lined up, I want things stacked on top of each other. So what we're going to start looking at is we're going to start looking to see if we have columns. In other words, are the x's stacked on top of each other? That's what we want. So standard form, if both equations are in standard form, then they're both ax plus by equals c, then they will naturally be stacked on top of each other. That's what we want. That's step one. See if everything is stacked. Is that y stacked on top of each other? And then are the constants stacked on top of each other? That's the first thing we're going to do. Okay? So it's already done for you. Now, step two was the first new thing. We want opposites. We want one of these columns to be opposites. So let me pause for a second. What do I mean by opposites? Could someone give me an example of opposites? Anything, just make it up off the top of your head. Go ahead, Martin.
Like math is anything.
I'm talking about math, not
opposites, so like 2 and -2.
Perfect example. 2 and -2. Could someone give me another example of opposites? Angela? 6 and -6. Another one? Those are the only ones? 2 and -2, 6 and -6. Tatiana?
9 and negative 9. Yeah, 9 and negative 9.
9 and -9? Good. Let's go to the equity bars and see if anybody else can come up with one. So student number 5, can you give me one? 5 and -5. Student number 7, can you give me one? 4 and -4. Student number 19, can you give me one? 1 and -1. Student number 3, can you give me one? Oh, you already gave me one. Student number 21, can you give me one? You already gave me one too. Student number 1.
10 and -10.
Beautiful. So these are all examples of opposites. So now we now remember opposites. So now what we want is we want a stack of opposites. So let's look. Do we have opposites highlighted right there? We don't have opposites. Okay. Let's look at the next column. Do we have opposites? No. Okay. And we're not worried about the constants. We're talking about opposites with the x's or the y's. So since we don't have opposites, what we have to do is make opposites. Okay, and here's something that you never learned before. To make opposites, what we are allowed to do is multiply an entire equation by a number. So let me ask you this question first. What number would we like to be right there so that these were opposites? What number would we like to show up there? Oh, we got a whole bunch of people who know. Diane? 3, because that's the opposite of -3. So now, watch what we're allowed to do. We are allowed to multiply this entire equation by a number. So what number should we multiply everything by so that a 3 shows up right there? Ethan? 3. We're going to multiply the whole equation by 3. And it's basically distributive property. It's not really, but it's basically the same idea. If we multiply everything by 3, it's going to be this. Multiply, multiply, multiply. And what we're doing is we're converting the equation into an equivalent equation. You know how we've talked about value a whole bunch of times, and I talk about money? $1, 4 quarters, same value, but it looks different. What we're doing when we do this is we're changing the way it looks, but we're keeping the same value. So this is going to turn into 3 times x. What do we get there? Danielle? 3x. So I'm going to write it underneath right here so it's stacked up nicely. So we got 3x. And what about 3 times the next term? 3 times 2y. What do we get there? Deja? 6y. Very good. So we get plus 6y equals, and now we have to do 3 times 11. What do we get for that final quadrant? 33. So now we converted it. Now watch. We don't need the original one anymore. I don't want you to erase it, but I'm just going to block it out just to kind of get it out of our way. We no longer need this because we basically rewrote the system into a better one. Okay? So that was something new for you. Here's the next new part. And here's the whole point. It's kind of a trick. We can now, like in elementary school, add down. And we add down in columns. So watch. This is now a column. What will happen when we add -3x and +3x? What will we end up with? Close. What do we get when we add -1 and +1? -1 and +1? We add them together? 0. What do we get when we do -5 and +5? Okay, so -3x and +3x? Very good. So we get 0. What do I usually say when something like this happens? I usually say something. I don't usually say 0. I say they, what, Ethan? They cancel each other out. These are going to cancel each other out. Now, next column. So now I'm moving over to this column and I'm adding straight down. Y and 6y, what do we get when we add those two together? Good. Angela? 7y, very good. Equals, and a -5 and a +33, that's simple mental math. What do we get for that? Go ahead, Danielle. 28. So we get 7y equals 28, and you can do mental math for that. What does y come out to?
4.
Y equals 4. And so we have just figured out half of our answer. Remember, we got to focus on what we're looking for. We are looking for an ordered pair, and we just figured out, that the y value is 4. So now we need the x value. What can we do to find the x value? Christian's going to help us out, even though he doesn't know it. What are we going to do now?
Like, five.
Yeah, but you were right. What was the first 3 words you said? Plug it in. And you can actually plug it in anywhere you want. But now I want you to look at this carefully. Which one would be easier to plug it into? You'll get the same answer either way, but which one would be easier, do you think? Aaron, which one do you think? Top equation will probably be easier because the y is by itself and we've got a 4 here. So, plug it in. But you could plug it into the second one. Do I have a brave person who's willing to plug it into the second one for us? Go ahead, Mark. You're going to be the brave person. Deja, you're going to be the brave person. You're going to both plug it into the second equation. Everybody else, we're going to plug it in together into the first one. So we got -3x plus, but now instead of the y, we're going to put the 4 equals -5, and now solve that equation. My really high-level students, there's a few of you in here who can actually solve that mentally. Go for it. If you can't, 2-step equation, you should be able to solve it quick couple steps. Give me a thumbs up when you've got it. Got 1, 2, 3. Wow, even my person who did it with the other equation. 4, 5, 6, 7, 8, 9, 10, 11. More than half the class. Good. Put your thumbs down. Diane, what'd you get for x?
3.
Get 3? Yeah. You get 3. So, the ordered pair, the solution to the system is 3, 4. Does anyone have any comments or questions about the process we went through? What do you think would happen if we decided to do substitution for this? Because prior to today, all you knew was how to do substitution. What do you think would happen? Aaron, what do you think would happen? Yeah, you get the same answer, no matter what, as long as you did it right. Get the same answer. Does anyone have any concerns or anything about what we did? So we went extra slow for the first one. We're going to go quite a bit faster now because remember, it's those new ideas that, it's like, whoa, I've never seen this before. Let's go a little slower. But once we've seen it once, and you guys are very bright, we can go a little bit faster now. Because now you know what we're looking for. I also said earlier that there was like a little shift in the way you look at things. Substitution, you kind of have to look at it in one way, and now elimination, we're looking at it a little bit differently. Because now we're looking kind of at the whole thing, and we're looking at, a stack. We're looking at a column. And we're looking for opposites in that column. So they're all stacked up perfectly. X's on top of X's, Y's on top of Y's, constants on top of constants. Now let's look for opposites. Do we have opposites there? No. Do we have opposites here? No. So we have to make opposites. Any suggestions on what we could do to make opposites? Isabella. Times what by -1? Which one? The top one or the bottom one? Okay, so that's one thing that I didn't talk about, is that in this first example, we multiplied the top equation. It doesn't matter, you can multiply the bottom one. But she is suggesting we multiply the top one by -1. Okay? Anyone have a different idea? Okay, so then let's just go ahead and do that. Multiply by -1. Let's see what happens. Anyone have a shortcut for multiplying by -1? Like, what happens when you do that? Von Travis? Yeah, all the signs just flip. So the 2x will become a -2x. The positive y will become a -y, and then the -5 will become a +5. And now, we got what we wanted. Opposites right there. So I guess Isabella had a pretty good idea. So now, add down. Elementary school, add down. Ethan, what was it that we said for these two? They cancel out. -5y and a -y. What does that come out to? Go ahead, Angela, you're on a roll with this. Yeah, that's -6y. And I don't need a volunteer for 13 plus 5, that's 18. And this is mental math. What does y equal? Go ahead, Ethan, you're on a roll also. -3. So we've got half our solution. Got half our solution. Y is -3. Now we need to, what was it that you said, Christian? Plug it in. You can plug it in anywhere. You can plug it into this one. You can plug it into this one. You can plug it into this one, because no matter what, you're going to get the same answer. Which one do you think will be the easiest one to plug it into? Which one will be the most efficient? Keanis?
The top one?
Yeah, the top one. Because we found y, and there's y right there. So if we do 2x, and now y is -3 equals -5, go ahead and solve that equation. My very high-level students could do that mentally without even doing the 2 steps. Give me a thumbs up when you got it. Good. Good. Gloria, what'd you get?
4,
We have the -3, so what, I'm sorry, so what number goes here? 4. Sure about that?
no.
Okay. Sorry, I guess my hesitation made you question yourself. Yeah, we don't get 4. You made a small mistake in computation. Deja, what do we end up with? We don't end up with 9, because if you plug in a 9 right there, you get 2 times 9 is 18 minus 3. It doesn't equal that. Natalie? We get a -1. -1. So you'll notice that I'm really not spending much time. I'm not even demonstrating the 2-step equations. For my students who made mistakes just now, it's okay. It's okay to make a mistake, but remember my expectation. You should be the grandmaster, level 9 of solving 2-step equations. That's why I'm not spending any time on it. If you're not at that level, you'll get there. Does anyone have any questions on how we went about this? On elimination? All right, so let's see how you do on your own. Checkpoint number 1, you got 2 of them. So 2 systems I would like you to solve, and I'll say 3 minutes on the clock and see how we do with that. we end up needing another minute, that's fine. I'll extend it a minute. I'm not a big deal, a minute or 2 minutes. Got about 30 seconds left. I even extended the time a little bit, so you should be okay. All right, now take 1 minute, team talk, and see if you guys agree on your answers.
Which one? You said negative 15 last time? Well, that's not yours. Change. Okay, well, could you?
Oh, I know. You're right.
Oh, I'm sorry.
Looks like this is there.
Oh, yeah, I'm sorry.
To be honest, the first one is coming
All right. So now let's get some people nice and uncomfortable. So equity bar is in effect. So I'm on question A only. Here we go. Question A, I got student number 17, 7, 16, and 19. Student number 17, what'd you get? I'm gonna put you in a special spot. Make sure you get included in the next one. Student number 7, what'd you get? Okay, student number 16, what'd you get?
Oh, see, I was the same as Tristan.
I saw your paper. I saw you do it. You have the
Yeah,
answer.
it's wrong.
It's not wrong. We just went over.
Wait, I
Student number 19, what'd you get? Oh, I'm going to call on that whole group again. All right, so for part A, negative 2 comma 0. Negative 2 comma 0. All right, for part B, what did you get? I got students number 15, 1, 6, and 8. Student number 15, what'd you get?
I didn't get it.
I keep hearing this, and I'm concerned. Student number 1, what'd you get?
Get to it yet.
Student number 6, what did you get?
I couldn't solve it.
Student number 8, what did you get? I don't know, ladies and gentlemen. Okay, maybe I went too fast. That's fine. My bad. So we'll see. So the correct answer is 4 comma 1. So let's go back. And I know that part A looked a little bit different all of a sudden, but if you paid attention to what I had kind of guided you on, you shouldn't have had a problem. I heard a number of people telling their teammates what they did. Could someone explain to us what you did first for part A? What did you do first, Kiana?
for part A, I multiplied 2 by top equation.
So you multiplied the top equation times 2 so that you could get opposites where? X's or Y's?
Y's.
You get the Y's opposite, absolutely. Give me a thumbs up if you did the same thing. Good, that's only a few people. Put your thumbs down. Anyone do it differently? Tatiana, what'd you do?
For a second equation, I multiply everything by 3.
Multiply the second equation by 3. If you multiply this by 3, you get opposites with the X's, right? But guess what? No matter what, you should get the same answer. Let's start with Kiana's method. She does 2 times everything. Remember, you have to multiply by everything, and you get 18x minus 8y equals negative 36. Now add down. This will cancel, and you get 15x equals negative 30, and I'm not sure why so many people had trouble. X is negative 2. Once you have one of the coordinates, the rest is easy. I'm not even going to waste time going over it. If you can't get the next coordinate after getting the first one right, then you've just got some basic computation issues that we've got to work out. It's not worth the time here. Now, had you done Tatiana's method of multiplying the second equation by positive 3, you would get a different result first, but it doesn't matter. You still end up with the same end result, which is negative 2 comma 0. Okay? Let's look at part B. What did you have to do to part B? I saw a bunch of people raise their hands when no one was able to answer it. What did you do, Angela?
I multiplied negative 1 on the first equation.
You multiply the first one by negative 1. And so you got opposites where? X's or Y's?
Y's.
Yeah, you got Y's opposite. Guess what? You could have multiplied the bottom equation by negative 1. Either way, you're going to get the same result because you're going to get negative 3 here. No matter what, you get the same result. So I'm not sure why we got stuck, but I guess we'll figure it out. Okay? Let's keep going and let's see if we can get even better. So, example 2. So first we want to see if everything is stacked up. Is everything in standard form? Well, I was nice. Already did that for you. Everything's stacked up. X's are stacked. Y's are stacked. Constants are stacked. So now we're looking for opposites. Opposites? Nope. Opposites? Yep. So guess what? Look back at the notes that we took way back at the beginning. Look what I wrote right here. And I know it was kind of worded a little strangely. Multiply none, one, or both equations. So there are cases where you don't have to multiply, you don't have to do anything, because the goal is to get opposites no matter what. If the opposites already exist, then you don't have to do anything except add the two equations together. We've already got opposites. Add down. As Ethan has said several times already, the opposites cancel out and add everything down. We get 7x, 5x, we get 12x equals 0. Solve the equation. X equals what? X equals what? Aaron? 0, of course. So we've got half of our answer done already. We now know that it's going to be 0 comma something. Now we just have to plug it in. Take the 0, plug it in anywhere you like. Looks like the first one might be nice. Plug in the 0 right there. We get 7 times 0 plus 2y equals negative 6. And since anything times 0 is 0, this basically disappears. And so we've got 2y equals negative 6, and that's mental math. So what do we get as the y value? Daisy? Very good. Negative 3. And so our ordered pair is 0, negative 3. Anyone have any comments, questions? With my high-level students, do I even need to do another example when the opposites already exist? No, I think our time's better spent by you guys trying it out. So let's see how you do with checkpoint number 2. Got one question. We seem to struggle a little bit, so I'll put 3 minutes on the clock so that you can discuss your answer with your teammates. There should be time for you to have your team talk already, so go ahead if you're all done. Or even if just two of you are done, you can go ahead and discuss.
Well, first, did you guys get
All right, colored pens up. Let's see how we did this time. I got student number 17, 19, 2, and 11. Student number 17, what'd you get? Student number 19, what'd you get? Student number 2. Student number 11. So the correct solution is -2, 4. And now, I did not ask you to do this, but now I would like you to take a moment and look at something. So what is this? Someone explain what I just revealed. What did I just reveal? Melinda? That was a beautiful explanation. The graph of the system. Yeah. I used a computer program to do it, but I could have done it by hand. I graphed the system, and what do you notice about where they cross? Where is it? It's -2, 4. Of course it is. That's the whole point. Is using elimination is a technique that allows us to skip over drawing this. It gets us this without having to draw the whole picture. That's the whole point. It's much more efficient. Does anyone have any questions about that? Okay, so now we are going to ratchet up the level of complexity a little bit, and we're going to finish off by challenging ourselves. But it's really nothing different. So we're still looking to solve a system. We're still looking to use elimination. So we're looking to see if everything is stacked up. So we can see the x's are stacked. The y's are stacked. The constants are stacked. But now we're looking for opposites. So no opposites, no opposites. But now we have a new challenge. Because even though we don't have opposites, like here in the first example, we didn't have opposites, but it was very easy to make opposites because all we had to do was multiply by 3 and we got opposites. And here all we had to do was multiply by -1 and we got opposites. But now it's a little bit more complex because I can't get opposites very easily here and I can't get opposites very easily here. So now you have to use your brain a little bit, and now you have a little bit more work, but it's really nothing different. You'll notice that way back in the notes, I wrote none, one, or both equations. So let's not worry about multiplying yet. Let's just talk about what is a multiple of both 3 and 2? Give me a number that's a multiple of both 3 and 2. Diane? 6. And I love how he knew instantly what I meant by multiple. Multiple, multiply, multiple. So wouldn't it be great if I could get 6 and a negative 6? In other words, I would like to change both equations so that it looked like this. Now, I don't know the rest of it, but I know that I want this column to look like this. So now, what do I have to do to the first equation to get this to turn into this? Good, we got a lot of people catching on. Go ahead, Natalie. I love the way you said that. Multiply everything by 2, and that will get us the 6 and then the rest. So let's go ahead and do that. Negative 10y equals 30. And what do we have to multiply the second equation by so that this turns into this? A bunch of people again. Angela? Negative 3. Make sure you pay attention to these negatives, because we need the opposites. We don't want the same number, we want opposites. And so again, multiply, 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 and we end up with negative 6x minus 12y equals positive 3. So now, forget about the original. Who cares? Now we've got it set up perfectly. We can now see the opposites right there. So now add down. That cancels. Negative 10y, negative 12y is negative 22y equals 30, and 3 is 33. Solve the equation. What do we end up with? Tasia? Very good. You said that beautifully. Negative 1.5. Negative 1.5, negative 1.5. Doesn't really matter how you say it. So we've got half of our answer. We know that we have negative 1 and 1/2 as the y value. Now we need to get the x value. So take this number and plug it in somewhere. Doesn't really matter where. You have 4 different equations to choose from. You can plug it in here, 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 or here. Doesn't matter. You will get the same answer no matter what. It looks like the second equation, this one right here, might be the easiest. I'm not sure though. Let's give it a shot. 2x plus 4 times negative 1.5 equals negative 1. Solve that. Got it? Give me a thumbs up when you got it. Yeah, mental math's a little bit harder here. Good. 1, 2, 3, 4, 5, 6, 7, 8, 9. Good, you can put your thumbs down. Diane, what'd you get? 3.5. Is that right? Emily, what's the tiny little mistake? Yeah, it's negative 3.5. Negative 3.5. Very good. And so we got, yeah, it was a little bit tougher, and we had to multiply both equations. We end up with some fractions. So you've messed up, Diana, a few times with negatives, and so that tells me that you know what you're doing. You just got to pay attention to those little details, okay? All right. So I'm low on time. That's my fault, not your fault. You don't get punished. That's just my issue. So I wanted to do more. I wanted you to at least get a chance to try it on your own, but we're not going to be able to do that. So we're going to end here, and I'm going to give you your assignment, but I just want to make sure we're clear that we are doing the same thing in all of these cases. And our goal is to build a toolbox, a technique that you can apply next time I see you. Because next time I see you, we're going to talk about real-world examples. And we're going to talk about how to solve them, and there's different ways to solve them. So, draw a line across your paper. Your homework is page 289, numbers 2 through 10, and 291 through 6. And you have a quiz on 5-1 to 5-3. Let's see. Today's Thursday, so you have it on Monday.